Hello everyone, welcome to another Connection Wednesdays. I'm very happy to welcome you again on our regular online training for engineers who are interested in steel connection design and code check, or for everyone who is interested to learn something about IDEA StatiCa. IDEA StatiCa connection is a great tool for design and code check of any topology of your steel connections. And this training tries to show you that it's really easy to use and very general for all the topologies. My name is Siana, and together with my colleague Adam, we will show you today two examples. The first one, sorry, before I skip to examples, I want to tell you something about the tool GoToWebinar. You are muted by default, but you can communicate with us via the question panel. So feel free to write us any question you have, and we will answer them during the webinar. And some of questions will be answered in the end if we have enough time. The webinar will take approximately 30 minutes. The questions that will not be answered during the webinar will be answered by email, so don't worry, we will answer all your questions, and please feel free to write us. And now what will you see today? So the first example, it's the customer project. This time is the engineering company from Turkey that allowed us to present their connection, which was designed and checked in IDEA StatiCa. So it's a very nice example. And and in the end, we will have a look at the material library that is implemented in IDEA StatiCa, so you can learn something about how to save your custom material. Now I will pass the word to Adam, who will tell you the introduction to the first example, and he will show you also the model. So Adam, please.
Yes, welcome from my side as well. Thank you for watching us and choosing our webinar instead of the Olympics in Pyeongchang. And I'll show you one example that we got from one of our customers that we are really proud of. It's the Galpan company located in Turkey. And this company provides the whole service for steel structures, beginning in the designing and manufacturing and installation at the end. And they do really nice projects in Turkey and also all around the world. As you see on the picture, this is one of the sports stadium in Turkey, just built in recent years. And they are using very massively the IDEA StatiCa connection, and we got a perfect feedback from them that how it saved many hours and weeks of work when they took advantage of our software. So we got very nice feedback, and we are proud to present this example. And the example is the 10 Burda Mall. It's the new design of a mall in the city of Balıkesir in the east of Turkey. And here again, they used the IDEA StatiCa connection to design and code check one of the steel roof structure of the main structure of the mall. And there is one specialty in the Turkey region that they use the metric system and American code to code check the structure or the joint. So I'll just jump right into the example, into IDEA StatiCa. So I'll just take the presenter now. And what we get here is the imported geometry. So we'll not start from zero, but we have the geometry imported, and I'll just click it through to show you what's interesting here. This is imported from a structure model from StatPro. So very easy way how to load geometry and internal forces and then just do the design in IDEA StatiCa. So we got all the geometry data here. And what's interesting on this joint that this is really complex. It's not maybe visible from the first look, but all the tubes, they are not in the same plane. So there are various angles in each tube. So it's completely out of plane joint. As I click through, you can see how the angles change here, the beta direction and gamma pitch. So this is very, very wild joint, and we can see if I switch to wireframe how they nicely meet in just one node. So last thing maybe to comment here that these two tubes here, this one and this one, has the restriction of the model type to normal and shear force only, because those are diagonals without any bending moment acting on them. So that's why it's set on this model type. So I'll continue to load effects, and just to remind yourself how to work with this section, if you import from a structural model such as StatPro software or ETAP, Skia, AirStab, or another softwares that we are linked to, you got all the forces, all the combinations here in the list, so you can load up to, I don't know how many you like, for example 50. But just to remind you, there's another way. Or you can always manually just input the forces like this, or you can import them from an Excel sheet, which I'm going to do now. We have the governing combination or the worst combination here that govern the code check of this joint. So I'll just apply this one. And here's one thing that I would like to point out that I just forgot to check the equilibrium on. So that's why it showed me two combinations, and this is something you shouldn't forget anytime. So always check the equilibrium, and then if I import, I'll be fine with the prepared forces. Okay, so we've got the forces imported, and then we can continue to the design and add some manufacturing operations to finish this job. So I will start with the easiest way, and to connect these 4 tubes by weld. So I'll use the cut command, and I will choose first this tube, and we'll connecting this tube to the main one, which is the 1097. And we will use cutting method surface, and we got the tube connected. I'll just change the electrode type to 80, and that's it. And now, very easy way how to do it for the 4 tubes as well. the best function in IDEA StatiCa design phase is the copy button. I'll just do this for the rest of the tubes. 1, 2, and 3. And we got all these tubes connected. Good, so that was the easy part. And now the diagonals that will be connected by a connecting plate. So I'll choose the connecting plate operation. And now I have to set it all fine here. So let's start. I'll choose the tube 899, which is this one. Will be connected to a new plate and related to the main tube 1097. Okay, we have something here already, so let's continue by optimizing the design. So I'll change the thickness, size of the plate and its position. Now move the connection, change the thickness of the connecting plate. I will move it to the rear side and set it as cap plate on both sides. So we have it now like this. And I'll continue the settings here. So plate length, width, and thickness of the cap plate and its offset. And I will change it to a circular plate that fits the design better. And I'll leave the bolted connection type, change the electrode quality to 80, and change the position of welds are okay. So we have something like this now. And the last thing will be that I change the bolt size 27, grade 8.8. And I will start the putting the bolts from the plus edge of the plate. So this is one way how to input the bolts, that we start from the plus edge, which is this one on the left side. And I'll just write the numbers to get it there. Okay. And last thing is the position. Good, so this is looking good. The last thing would be to probably do something with this connecting plate, because this is interfering with the tube and so on. So for this, we use the editor function, and we'll be editing the gusset plate. So here we can add another operations to work with the plate. So I will add first a bevel, and I will cut this plate to a better shape that fits the design. So bevel operation will look like this. I will add another bevel. I'll just use the copy button here and input desired values like this. Then I will add an offset. I don't want the whole outline, but just on the edge number 3 and the offset value of 50. Then I will add chamfer, and I will chamfer the edge number 1 and also just copy it for the edge number 4. Okay, and let's see what it does. Okay, so this is looking much better, right? So we're done with this one. And now the next one And I will, of course, oh, sorry, I forgot to add the stiffening plates on the side of the connecting plate. So let's do first that. So I will add a stiffening plate operation. And again, set it to the right position and change the size of it. And the origin will be the connecting plate, CPL1A, and type RIP, location front, and we'll just move it and rotate it. Okay, so this is it. I'll change the electrode type, and this time I will turn off the weld because I will be adding weld in the next operation. But here I will edit the connecting plate a little bit. So I will again use the chamfer operation, value of let's say 80, and I will use the copy function here for 1 and 2 corners. Okay, so now it looks like this, and I will just now cut this plate by the tube. So I will add another operation, cut of plate, and I'll be cutting the SP1 plate by member, which is the main tube 1097, and I'll use the surface cutting method. Okay, got it there, and I'll choose the weld quality and double fillet welds for this operation. All right, and now I'll just copy this for the other side of the connecting plate. This is 510 to get it to the right position, and also the P-cut operation. I'll just change for the SP2, and a simple way how to just duplicate such a plate. Now I will weld these plates together as well. So let me do that. I will add a weld operation, weld or contact, and I will now choose the CPL1A, edge number, let me see, this one, so it's number 4, and I'll be connecting the SP2 plate. Okay, and the weld is there. I'll just choose the double fillet weld and change the quality. Now I copy this for SP1 and the edge number 8. Okay, let's see the view. Welds are in the position. So this part, or this diagonal, is fully connected, fully designed, and we can move to the second one. So let's see. I will just connect the, copy the connecting plate operation that I have already done, and just switch it to 706 tube. So we got the design here, but the tube is smaller and the angle is different, so we have to change some values in the operation settings. So I'll just go quickly through it. I'll change the size, position of it, size of cap plate, and its thickness, the offset value. Okay, and let's choose the smaller bolts. Put them in the right position, like this. Okay, so this is looking better. And now the last thing is to edit the gusset plate. So again, we go to Gusset editor, and I will now change the values here as well. 170. So now BL3 will be 180, 160 for corner 3. Let's use the offset. There is one trick. You can also offset in the minus or the opposite direction. So we'll actually grow and not offset the plate. And this is for stage number 3. And for the chamfers, I will leave it for 1 and 4. And let's see the change. Okay. Better look. And now I'll just copy the stiffening plate for this connecting plate, which is CPL 2A. Okay, we got it here. And I will also copy it on the other side. So like this. And I will just weld them all together. So I will again copy the P-cut. Now I will say I want to cut the SP3 by the main tube. Okay, and copy this for the last SP4 as well. This is also connected. And now the last thing, I will copy the weld to weld the connecting plate and the stiffening plates here. So CPL 2A and SP3. And this time the H index is number 8. Okay, we got the weld in position. And the very last operation is to weld those two plates here, connecting plate and SP4. Oops. Okay, and the H index this time is, if we switch to transparent, we get a better view, number 4. So this is done. We've got the design finished, so let's jump quickly to check because we're running out of time. And just while the calculation, I'll show you I was talking about the import from StatPro. So you can check this on your own, how to do that and how it can help your workflow. If you go to ideastatica.com, resources, here you click IDEA StatiCa Steel, and you can see in the tutorial section, BIM, and here is StatPro link, and you can see the video, how it's done, how it does it work, and step-by-step tutorial, how you can import a joint from StatPro and get it to IDEA StatiCa with the geometry and all the load combinations. So you've got all the other softwares here listed and described just as this one. So just take a look there and see what you got. So this is still calculating. I can maybe, just to save time, switch to already calculated project that I have here as a backup, because we already spent almost half an hour for this presentation. So here is the project calculated. We can see quickly the overview: gray, green, orange color, all is fine. We passed all the code checks with the worst combination imported. So just quick overview. This is also a very good and economical design because we are on the limit actually. One weld is up to 98% of its capacity, and overall this design is just good. So you can see and check just the equivalent stress, plastic strains, and so on. I think all the features that you already know, or you can try on your own. So this was from my side, and now I switch presenter back to Jana, who's going to discuss the material library.
Okay. Thank you, Adam. That was a really complex join, but you can see that even such connections are possible to model, but also the simple ones. The simple ones are really fast and also very easy. So IDEA StatiCa is really a general tool.
And complex are fast and simple are super fast.
Okay, yeah. Okay, so and like in one of our previous webinars, someone of you asked if we can save somehow the custom materials and use them in another project. So definitely you can use it, and I will just very quickly show you how it is done. So I have such an example of connection in IDEA StatiCa, and if I go to materials and steel, concrete, I have a list of all the materials used in this project. If I, for some reason, added the material, for example, steel. So let's say I just want to change the ultimate strength of the steel for some reason. I will change it, and now I can save the material. I can put some name. Okay, I will call it just my steel 235. And now where the steel is stored. In the top ribbon, there is MPRL, which stands for Material Properties Range Library. And if I open it, I will see that my steel was saved in this library. This library is saved in the temp files on my computer. So whenever I open some project on my computer, I can choose of such steel. Okay, if I can do the same with the bolt. So let's see, I will just I will just change any parameter. So this is again another example. I change the steel of the bolts, but I can also change the geometry of the bolt set. So if I want to maybe have bigger holes for my bolts, again I can save it to MPRL. And now if I will show you that when I start a new project, I can open this material and in the new project as well. So here I can see that my steel is here, And okay, and just very quickly, if I will just make it very quickly. So I apply some template, and when it asks me for the bold grade, I can see that I have also my M24 bolds here. So beside the standard library for Eurocode or American Canadian code, you can also create your own materials that will be stored. And what more, you can also export the library and send it to someone else. So you can share your materials in your company, and it really saves time. Okay, yeah, we are a little bit over the time, but I hope it was worth. So thank you very much for your attention. I think we didn't have any unanswered questions. After the webinar, you will be asked to fill a very short survey. It will take you just half a minute. And so please give us some feedback. We really appreciate when you write us what do you think about this webinars. And if you want to play the record of the webinar, it will be till tomorrow on our YouTube channel and also on our webpage. And everyone who wants to try IDEA StatiCa is really welcomed. Please go to our webpage and download the trial version and try to model your connection in our software. And also, if you want to, if you maybe are proud of some of your connection and you want to share it with others, we'll be really grateful if you send us your project, and we will show it in one of the next Connection Wednesdays. So we will see each other again on the 7th of March. It means in 2 weeks. So I think that's really all for today. Thank you for your time once more, and have a nice day.
Have a nice day, and thanks once again to Galpan Company. Bye-bye.
Goodbye.